one here, it tells us that the graph of f was moved by 1 unit to the right. Okay? For the graph of h of x, the graph of h of x, we can describe it or explain it in terms of the graph of both f and g. You didn't come here to do that. Right? The graph of h is actually the graph of f if we move f by 2 units to the left. So we've got this plus here, that plus 2. It indicates that the graph of f was moved by 2 units to the left. Therefore, the turning point which was here, it moved to that point. The turning point is now at x equal to minus 2 and y equal to 0. Also, the graph now has a y-intercept which is equal to 4, which is here, because of that horizontal shift. Right? So, first thing, we can explain or describe the relationship between f and h. We can also connect the graph of g and h. If you move the graph of g by 3 units to the left, you will get to the graph of h. So the transformation that results in the formation of the graph of h can be explained in 2 ways based on the 3 functions that we have. Okay? F is related to h. That is, if you move the graph of f by 2 units to the left, you get the graph of h. If you move the graph of g by 3 units to the left, you get the graph of h. Right? Now, this is not very difficult. Everything else we are going to do from now on is just playing around with the basic graph, this one here. We are going to move it up, down, left, right. Okay? So, for today's work, before I carry on, right, remember this exercise was mainly on the sketching on horizontal shift. Now let's get into the details now of the properties that I spoke about in the last lesson. Okay, so I'm going to start with an example. So let's sketch. Okay, let me write the example here. So now I'm going to incorporate both vertical shift and horizontal shift. I'm going to incorporate all of them. Okay, so we need to sketch the graph of f of x equal to, well, let me start with a simple one. Right, x plus 2 squared minus 1. We're going to sketch that. Right, now just as a way of reminding you, this plus 2, it indicates horizontal shift by 2 units to the left of which graph? Of the graph of y equal to x squared. This minus 1, it indicates that there is vertical shift by 1 unit downwards. Of which graph? Of the graph of x plus 2 all squared. Okay? Now, in other words, we can also explain it by saying, if we shift this graph here, y equal to x squared minus 1, okay, by 2 units to the left, we will get the graph of f of x. So there are 2 ways of explaining. Either you can start with the vertical shift, or you can start with the horizontal shift. Either way will get you to the same point. Okay? So let's sketch that. Now, first thing, if you want to sketch, because this graph is slightly more complex as compared to the grade 10 graphs. Can you stop that? Move it down. Alright, so let's determine the shape first. Now, your shape is determined by the value of A, which is a number which is outside the bracket here. In this case, it's going to be a positive 1. So A is positive, therefore the graph is happy. Okay, A is positive. What do I mean by A? I'm referring to the general form y equal to A times x plus p squared plus q. That's the turning point form in grade 11. So this A here, it is a value which determines the shape of the graph. If it's positive, the graph is happy. Therefore, the graph will have a smiley face. If it's negative, the graph is unhappy or it is sad. Therefore, it will have a sad face. Alright, so the shape will look like that. Then, let's find the y-intercept. Now, your y-intercept, you get it by substituting x equal to 0. So we substitute x equal to 0. Now, unfortunately, we can't determine by inspection the y-intercept. You have to substitute x equal to 0. So f0 is going to be equal to 0 plus 2 squared minus 1. And this will give us 2 squared minus 1. And that will give you 4 minus 1, which will be a 3. So the y-intercept is going to be equal to positive 3, which means the graph will pass the y-axis where y is equal to 3. Okay, let me. Okay, if you miss it now, tough luck next year. Alright, so let me get on it. So I found my y-intercept by substituting x equal to 0. And I got y equal to 3. Now I need to find the x-intercept. Well, the x-intercept requires me to solve a quadratic equation because this is a quadratic function. So let me do it on the next page nicely. So the x-intercept you substitute f of x to 0. Okay, so the equation of the function is f of x equal to x plus 2 squared minus 1. Right? So what you do is substitute 0 there. You get x plus 2 squared minus 1. Right? Now, I just want to give you a tip. If you are given the equation of the quadratic function in turning point form, you don't need to rewrite it to this form here. Ax squared plus bx plus c. If you want to determine the x-intercepts, you don't really need to. But if you decide to do so, you still get the same result, but you spend more time. So what you can do here, take the negative 1 to the left, you get positive 1 equal to x plus 2 squared. You have done equations on sets, term 1. Okay? You take square roots on both sides. Remember to put plus or minus on the left. Once you take square roots on both sides, on the left here you get positive or negative 1. On the right, you get x plus 2. Okay? You get x plus 2 because the square root of x plus 2 squared is x plus 2. Now, this is an indicator that you have got two values of x. Okay? So, from here, we can say x plus 2, if we take the positive, we equate that to 1. And then also x plus 2 equal to negative 1. If you solve this, you get x equal to negative 1 or x equal to negative 3. So what this means is your x-intercepts are negative 1 and negative 3. In grade 10, your x-intercepts had the same value in terms of magnitude. If you got a minus 1 first, the other one will be a positive 1. If you got a negative 3 first, the other one will be a positive 3. In grade 11, That's not the case, because the y-axis is no longer the axis of symmetry because of horizontal shift. The y-axis is no longer an axis of symmetry or a line of symmetry. Therefore, you won't get values. If you forget about the negative or positive, you won't get values with the same magnitude. They won't have the same magnitude. So that is gone now from grade 10. Okay? So I found the X intercepts. I know my shape, I know my y-intercept. The next thing, well, I just need to determine my turning point. The good thing is, in grade 10, you don't need to do a calculation to determine the turning point. The turning point, if the equation is in the turning point form like this, it means that the x value at the turning point is going to be -2. Okay? It's the opposite of what you think. And the y value will be -1. So our turning point, I'll just note it by TP, is going to be at x equal to -2 and y equal to -1. Remember, the turning point, it's a point on the graph. You have to write it as in terms of both x and y as ordered pairs. See these two important. In most cases, it won't be requested, unless it's requested. What do you want? Okay. You know something? I've realized that there are some. Okay, so our equation of axis of symmetry is x equal to -2. Now, let's sketch. Please remember, this is a sketch. Okay? Pay attention as I sketch. Right? So, first thing, when you're sketching the quadratic function, you must start with your critical points, your x-intercepts, your turning point, y-intercept. But you must also know your shape, how the graph is going to look like. Okay? You can't sketch blindly without knowing the shape. So I know that my shape is supposed to have a minimum turning point. I've got my y-intercept, so let me plot the critical points. Right? I'm plotting first. Okay? So I have x equal to -1 as an x-intercept and x equal to 3 as an x-intercept. I also have my turning point at x equal to -2. Let me check that. Let me check. Okay. X equal to -1 and -2. Okay, I made a mistake with the turning point. So let me, because I was starting to think y is not, so -3 is here. So that's -1. Right? My turning point is at -2 and -1, which will be here. Right? And then my y-intercept is at this point. Y is equal to 3. Right? I know that my graph is a minimum turning point, so when I sketch it to look like this, well, it's not high because I would want, let me redo it. Okay, from here now I need to be straight. Okay, it looks something like that. So if you were writing a text and you sketch like that, then you get 1 mark for the shape, right? Another mark for the x-intercept, the third mark for the y-intercept, right? Now, let's add some information about this graph, more properties. Domain, range, right? Also, let me add the axis of symmetry. The axis of symmetry is going to be this line. Okay, let me use a different color. Green will be better. So this will be the axis of symmetry. Okay? Its equation is x equal to -2. That's the equation of that line of symmetry. Right? Then we can write the domain. The domain of any quadratic function, its x is an element of real numbers. That is, from minus infinity, we can write this as minus infinity is less than x is less than positive infinity. Sorry, you two. Hey, are you part of the lesson or what? Can you put away that piece of paper? Right? Then the range. Now your range, the way that you used to write it in grade 10 is exactly the same. You identify the value of y at the turning point. So the value of y at the turning point is -1. So the minimum value of y is a -1. The maximum is positive infinity. So we can write this as y is an element of real numbers, but y is greater than or equal to -1. You can also write this using the, the brackets. You can write as y is an element. Now, since we are including -1, we put a square bracket, and then we put plus infinity, and then we put a circular bracket. That's another notation. Right now, I'm marking the metric paper 1, the question on functions. It's terrible. A number of metrics, they can't write the domain, the function. Some can write the range. We are in metric 6. And functions are taught in grade 10 and 11, the bulk of them, especially the quadratic function, is mainly taught in grade 10 and 11. Don't think that when you are in metric, you have plenty of time. All right. Can you put your... All right. So I've got the domain, the range. Now, you may also be asked for what values of x is the function increasing, decreasing, and so on. Right? But for today, I'm going to stop there.